Thank you all for this opportunity. I am Ahsan Ali. I'm a research scholar at IIT Madras, working under Professor Ramakrishnan. So today I'm here to present my work, Characterization of Fornix, Structural Changes in Control, MCI and AD using structural MR images and rotational invariant moments. So I would like to start, this would be the content for the presentation. I would like to start with an introduction. And with the introduction, I would like to tell about the cognition, which is a mental process involved in brain activities, awareness, perception, planning, reasoning, etc. Whereas cognitive impairment is known as a decline in cognitive abilities, which progress in a loss of memories, language execution, visual, spatial, etc. And Alzheimer's disease is a progressive neurodegenerative disorder, which is an accumulation of beta amyloid plaques, which leads to cognitive decline in affected individuals. Whereas mild cognitive impairment is known as a prodromal stage of AD, and which is characterized by impairment in cognitive functions. These AD conditions affects various subanatomic structure of the brain, including Fornix, which is a white matter structure and a structure responsible for regulating emotions, memory, and learning, etc. So this is the literature review, and in the literature, atrophy in brain, enlargement in lateral ventricles, deformation in brain and brain stem, and decrease in frontal gyrus volume has been reported. So in my case, I have taken a Fornix, which is a thin or anarchic structure. So the motivation behind the study is the diagnosis of MCI is challenging due to the involvement of multiple brain subanatomic structures, and structural magnetic resonance imaging is predominantly used in the diagnosis of AD for its high resolution and soft tissue contrast. The analysis of individual brain regions in structural magnetic resonance images may not be sufficient to fully characterize the stages of AD. So that's why rotational invariant moments, in short RIM, are used to quantify the information from the multiple brain structure affected due to MCI and AD conditions. The aim of this study is to differentiate MCI conditions from normal and AD subjects using brain structural MR images and rotational invariant moments. For this, the objectives are first to skull strip the images and register for those. Then the delineate Fornix brain structural anatomic delineate the Fornix brain structure from the pre-processed images, and then identify the imaging biomarkers which can characterize the early changes in the progression of AD, and then formulate rotational invariant moments to differentiate MCI stages from AD conditions. This is the proposed methodology which is adopted in this. So for that, ADN database is taken, which is openly database, and after that images are pre-processed. In that, skull stripping and special registration is carried out using FreeSurfer, and the segmentation of Fornix is carried out using reaction diffusion level set algorithm. From the segmented structure and rotational invariant moments, first, second, and higher orders are extracted. After that, the statistical analysis is carried out. This is a database description. In that, ADN is taken out, which is a 60 years database. 50% gender mix, around 50% population is group, and 1 cube millimeter is the resolution of the image with a 3 Tesla. The segmentation of level set, reaction diffusion level set is a age-based active contour which is implemented to segment Fornix. For that, the evolution equation of the level set is given by equation number 1. In that, f is a force function controlling the motion of the contour, and mod of delta phi is an inward normal direction in the in which the contour moves. In that, stability is increased when the reaction diffusion time is added, which is delta xi delta phi in equation number 2, where zeta is represent a small positive constant and delta is Laplacian operator. And for this, the force term for level set is given by equation number 3. In that, lambda and v are constants used to converge the curve towards the object. When f is put in equation 3, the final reaction diffusion level set equation is given by equation number 4. In that, g is a stopping function, I is the image, G sigma is a Gaussian kernel with standard deviation mu are parameters. For this algorithm, the parameter values are considered zeta 0.1, sigma rho 1.5, sigma 1.5, v 0.2, lambda is equals to 1, and with 100 number of iteration. Other than this, if the iterations are more than that, the structure is going under segmentation. And if the iterations are less than that, then structure are over segmented. So this was the optimum taken after a hit and trial method. The features. So moment is a scalar quantity which is used to depict the function and capture its essential characteristics. And the rotational event moments are moments which remains invariant under image rotation using the complex moments which are independent and offer robustness. And so for the mathematical equation for this in polar coordinate is given here. From that 11 rotational invariant moments are derived, which are listed here in the box. So the results. So these are represented brain structural MR images. We can see structures such as nose, eyeball, spinal cord are present, but the intensity of these non-brain tissues are overlapping with the brain structures. And these images differ in size and orientations also. And edges of the brain structures are not clearly defined as well. So these are pre-processed images. I have shown on all the three sagittal, axial, and coronal views. So after pre-processing is image are stripped. So in that one we can see that non-brain tissues such as nose, neck, spinal cord, and fat are removed from the pre-processed images using the free surface pipeline, and the intensity is also normalized. And we can observe that the white matter and cerebellum they are visible in sagittal views, whereas gray matter and ventricles they are visible in axial and coronal views. But Fornix is not much visible in other views other than sagittal view. So for that, I have taken sagittal view for the segmentation of these images. The Fornix is clearly visible as a C-shaped structure, and the intensity of the Fornix overlap with CC, corpus callosum, and brainstem, which is challenging during the segmentation. In that case, level set techniques, which is capable of segmenting Fornix from other brain structures, and the disease-related abnormalities are not visible from these segmented images. For that, features are required. So this is a rotational environment moment feature. This is a histogram distribution. In that one, we can see that mean values of moment 1 and 7 are increasing from NC to MCI and AD, which shows a high degree of discrimination. It may be due to the fact that first order moments are highly sensitive for capturing the basic properties of the Fornix images. So this is a table which has given a mean and standard deviation of the all 11 moments, and along with the ANOVA results. So from this table, it is clear that it is there that ANOVA test revealed that all the moments are statistically significant, and in that moment 1 and 7 are observed to be most statistically significant feature. And right side is a percentage difference of those features. So in moment 5, the highest PD percentage difference is observed, and higher order real moments have high PD in all the moments. This may be due to the fact that higher order real moments are more sensitive to symmetrical features to high order imaginary moments, whereas high order imaginary moment can capture asymmetrical features which are more susceptible to noise and less stable. Summary and the conclusion: the brain structural MR images of NC, MC, and AD are obtained from the Adreno database. From there, raw images are skull stripped and specially registered using free surfer. From there, the maximum area slice is selected for the analysis. Then Fornix is delineated from the sagittal structural MR images using reaction diffusion level set method. Then from that total, from there 11 moments are extracted and no visible differences in segmented Fornix for NCMCI images are no visible differences is found in the segmented Fornix for NC and MC images because it is very small and similar in all the groups. Sorry. And the computer-aided diagnosis approach are essential for differentiating of MC and AD stages. The future studies, the future scope is to delineate Fornix volume and validation of the segmented Fornix structure against ground truth images after getting generated from the clinicians and extraction of more orthogonal moments, geometrical features, etc. from the structure for the differentiation of MCI conditions and formulation of the feature set for the classifier. These are the references. Thank you.